Hello everyone, in this lecture we will discuss about batch reactor. Now what is batch reactor? Batch reactor. Batch reactor, it is used for small scale production. It is used for small scale production. It is used for small scale. Usually it is used in labs. It is used in labs and it is used for small scale production. It is used when there is expensive for the production of expensive material. When the product is expensive products, for the production of expensive products, or it can be also be used for the production of explosive material. It is used for small scale production. So this is a batch reactor. In batch reactor, the reactant, we put the reactant in the reactor and stir it. These are the reactant. Suppose A is converted into B. We put the reactant. These are the reactants. We put these reactant in the reactor, and after some time the reaction take place and the product are produced. These are the products. Are B is produced after certain time, and we remove the product from the reactor. This is the batch reactor. Suppose isomerization reaction. Suppose isomerization normal butane. Suppose normal butane is converted into isobutane, or isobutane converted into new butane. It can be take place in the batch reactor. This is the simple example of graphical. This is the diagram, simple diagram for batch reactor. Now there is some advantages of batch reactor. What will be the advantages? Higher conversion take place in batch reactor. Conversion is high in batch reactor, and it also takes small space. And higher conversion. But there is some disadvantage in batch reactor. Drawback. There is some drawback of batch reactor. High labor cost. One drawback is high labor cost. The second drawback is quality of the product changes from batch to batch. Quality of product changes from batch to batch. Quality of product changes from batch to batch, and it take long time. The main drawback of batch reactor is it take long time for reactant to convert it into product. Sometimes it take 24 hours, sometimes it take 2 days, or up to many days it take, and this is the main drawback of batch reactor. So we can use continuous reactor instead of batch reactor in industrial or for large scale production. So it is for small scale production. Batch reactor is used for small scale production. Now, as we know that the general mole balance equation is input minus output plus generation plus generation is equal to accumulation. Now for batch reactor, suppose this is the batch reactor. The batch reactor, there is no input and no output. So generation is equal to accumulation, and in symbolic form we can also written for reactant A, which is Fa naught minus Fa plus rate of A in the volume change in A divided by change in time. Now input and output, there is no input and no output in the batch reactor, because once we put the input the material, and after some time we remove the product from the reactor, so there is no input no output in the batch reactor, so this term become 0. Now the generation is equal to accumulation, so the generation of component A is equal to the accumulation of component A. And in batch reactor there is one assumption that the rate of A is same in all space. There is no spatial variation. Suppose the rate of A in this space and the rate of A in this space will be equal. Similarly, the rate of A in this space are also equal. So there is no variation in the rate of reactant in the batch reactor, but it can be changed. After some time, like after 10 minutes or after 1 hours. The rate in this space can be changed after some time, but at one time the rate in this whole volume is same. It is considered that the rate in this whole volume at a time is same, but it change from time to time, and at one time the rate in this volume is same. So there is no spatial variation in the batch reactor, or there is no spatial variation in the space. So no spatial variation. So if there is no spatial variation, then this equation can be written as this. So if there is Ra dV is equal to dN A divided by dt, when there is no spatial variation, then Ra will be constant. And Ra is equal to dV dNA divided by dt. Now we can rearrange this relation dNA by V into Ra is equal to dt, or we can also write it RAV is equal to dNA change in time, or change in time is equal to change in the mole of A, rate of A in the reactor, and volume of the reactor. Now take the integral from 0 time to some time. At time 0 the mole of A will be in A naught, initial mole, and at some time the mole of A will be in A. So this is all the integral form for batch reactor. Integral form of mole balance for batch reactor. This equation is the integral form. Thanks.